Hello and welcome to another episode of CSEC Math with Sir Kumar. In our last episode, we looked at solids and more specifically, we looked at the nets of solids. Today, we're going to continue with solids, but we're now going to go to the individual solids and we're going to find the volume and the total surface area of those solids. But before we go to that, let's first define what is volume and what is total surface area. So get your books, pencil, pens, and let's get into it. We're now going to look at the definition of volume and total surface area. Now, what is volume? Volume can be defined as a three-dimensional space enclosed by a boundary or occupied by an object. Volume of an object is measured in cubic units such as cm cube, meter cube, etc. Now, the space enclosed by a boundary or occupied by an object. Here we have a three-dimensional shape. The volume of this shape would be the space inside of this shape. So when we're finding the volume, we're actually finding the space inside or the space that we would need to fit this object somewhere. So let's say we're packing a box and you have cubes of this size. You would have to find the volume to know how many of these could fit into the box that you're trying to pack. So it's either the space it occupies or the space enclosed by its boundaries. The next one is, what is total surface area? And total surface area is the area of all the faces outside of the object. Again, if we look at the cube, we have 1, 2, 3, 4, 5, 6 faces. So to find the total surface area for this shape, we'd have to find the area of all 6 of our faces and then add them up. Now, why do we need to find total surface area? Let's say you have a ball, a baseball for example, and you would like to cover it. So when you find the surface area of that ball, then it would say how much leather you would need to cover that ball. Or if you're wrapping a gift, it would tell you how much paper you would need to cover your present, your box, if it's a cube or if it's a cuboid, whatever it is. Now, apart from total surface area, you're going to hear about curved surface area. When you're looking at the sphere and the cone, you would come across the concept of curved surface area because the surfaces of those two shapes are curved. So it's the same thing, but instead of total surface area, you would see CSA, which is curved surface area. The first shape we're going to look at is the cube. So the volume of a cube and the total surface area of a cube. Let's look at the shape here. So the first formula for volume is V is equals to L cube. Now L cube, where L is the length of one side. When we're looking at L cube, this means L multiplied by L multiplied by L, right? Because we multiply our base by the number of times we have the power. So it's 3 times, so it's L times L times L. Now, L, in this case, because it's a cube, all the lengths are the same. So if this is 5, then here is 5, here is 5, right? So it's just like if you're going to say length times breadth times height. But in this case, since all is the same, we just say L cube. Now, the total surface area formula. We have 6 faces, 1, 2, 3, 4, 5, 6, and each face is a square. And if you could remember from our area lesson, we said to find the area of a square, it's L square. So since we have 6 faces, we know that we have 6, right? Because it's 6 faces multiplied by the area of one of our faces, and the area for one of our faces would be L square. So your total surface area formula is 6L square, where L is the length of one side. So the two formulas that we're working with is volume equals L cube and total surface area is equals to 6L square. Now let's use these two formulas to work the example that we have across there. Now you have a cube here. Calculate the volume and total surface area of the shape below. And if you notice, they only gave us 7 cm. So since we're dealing with a cube, this is 7, here is 7, all around the shape is 7 cm. So let's use our first formula, V equals L cubed, to find the volume. So V is equals to L cubed. V is equals to L, which is 7 cm, all raised to the third power. So the volume is equals to 7 times 7 times 7, which is going to give me 343 cm cubed. Remember, we said that when we're dealing with volume, our unit is cubic. So the volume for this cube is 343 cm cubed. Let's go and find the total surface area. The formula is 6L squared. That would be 6 multiplied by 7 cm all squared. That would be 6 multiplied by 7 squared is 7 7s 49. That's going to be 49 cm squared. And 6 times 49 is going to give me 294 cm squared. So this is the total surface area of this cube, and here you have the volume of this cube. The second shape we're going to look at is the cuboid. So the volume of a cuboid. To find the volume of a cuboid, the formula is length times breadth times height. And in some cases you would see length times width times height. Width and breadth is the same thing. It's the width or how wide the shape is. So the volume is length times breadth times height, or length times width times height, whichever one you see, it's still correct. Where L is the length, B is the breadth, and H is the height. So the length would be the longer side, the breadth would be how wide is our shape, and the height would be how high is our shape. Now we have to find the total surface area of this shape. So let's go across here. We have the cuboid with all faces are rectangles, and we have 6 faces. Now the faces usually come in pairs. So for example, you have the front and the back, the 2 sides on the top and the bottom. So to find the total surface area, we have to find the area of those faces. So let's start with the front. So it's the front and the back together. So to find the area of the front, it would be the length times the height. So that would be LH, and since we have it the front and the back, we have 2 shapes, so it's 2 multiplied by LH. To find our side, again we have this one side and we have the side in there. That's going to be 2 sides, and it's going to be breadth times height. So it's going to be 2BH, and the top and the bottom, so let's call it the top, is equals, again we have 2 faces, top and bottom, and it would be the length times the breadth. So that would give me the top. So that would be LB. Now front, side, top. So it's front and back, the 2 sides, and the top and the bottom. So the total surface area would be the sum of all of these. So the formula would be total surface area is equals to 2LH plus 2BH plus 2LB. And if you look at it, each term we have the 2 common, so we could factor out the 2. So the total surface area formula is equals to 2 into LH plus BH plus LB, where L is the length, B is the breadth, and H is the height. So our formula for total surface area would be this: 2 into LH plus BH plus LB, where L is the length, B is the breadth, and H is the height. Let's look at an example for the volume and total surface area of a cuboid. So we have a cuboid here with length 7 cm, breadth 4 cm, and height 3 cm. So to find our volume is equal to length times breadth times height. That is going to be length, which is 7 cm, multiplied by the breadth, which is 4 cm, multiplied by the height, which is 3 cm. And when we multiply 7 times 4 times 3, that's going to give me 84 cm cube. And this is the volume of this cuboid. Now let's go to the total surface area. So the total surface area is equal to 2LH plus BH plus LB. So let's start substituting our values. So this is going to be 2 open bracket. Let's leave out our units and just work with the numbers. So LH would be 7 times 3. So the first part would be 7 multiplied by 3 plus BH is going to be 4 times 3 plus LB is going to be 7 times 4. So since we already substitute our values, let's simplify. So this is going to be 2 into 7 multiplied by 3 is going to give me 21. Let's add our units here. Cm squared plus 4 times 3 is going to give me 12 cm squared plus 7 fours, that would give me 28 cm squared. 2 into 21 plus 12 plus 28 is going to give me 61 cm squared. 2 multiplied by 61 is going to give me 122 cm squared. And this is the total surface area of this cuboid. The third shape we're going to look at is the cone. So the volume of a cone, the formula is V is equals to 1/3 pi r square h, where r is the radius and h is the perpendicular height. Take note of h and perpendicular height. Remember I said perpendicular height would be the height that forms a right angle, so it's either given in the center or in some cases it's given outside. And you have the curved surface area in this case instead of total surface area because it's a round. The curved surface area is equals to pi r L, where r is the radius and L is the slant height. And take note of this one, L, and then you have slant height. So h would be our perpendicular height and L would be our slant height. So just remember, you could either get the perpendicular height inside, or if they gave you it out here, this is h. And the one that's slant, which would be the length of one of these slant side, it's L. So we have h and we have L. Very important when you're using the formula to note when we have to use h and when we have to use L. Now you have an example here. Calculate the volume and curved surface area of the shape below. Volume is equals to 1/3 pi r square h. Here you have h, which is the perpendicular height. Here you have our slant height, and the radius is 7.5 cm. So let's substitute these values into our formula and find the volume. So V is equals to 1/3. Can remember that pi is 22/7 multiplied by our radius squared. That means it's 7.5 times 7.5 multiplied by h, perpendicular height. That's the one outside here, and that's going to be 18. So let's make them into fractions. We put them over 1, and then we multiply all our numerators. So 1 times 22 times 7.5 times 7.5 times 18, that's going to give me 22,275. And here you would end up with cm cube divided by 3 times 7, that's going to give me 21. V is equals to 22,275 divided by 21 would give me 1,060.7 cm cube. And this is the volume of this cube. Now let's go find the curved surface area. So the curved surface area is equals to pi r L. This is going to be pi, which we know is 22 over 7 multiplied by our radius, which is 7.5, multiplied by L, and this L would be our slant height. That would be the one out here, and that's going to be 19.5. Make them into fractions, we put them over 1. So multiply our numerators. 22 times 7.5 times 19.5 is going to give me 3,217.5 divided by 7 times 1 times 1. That's going to give me 7. And when we divide it, we get 459.6. Our unit is cm. And since we're finding area, it's cm square. So this is the volume. Remember, the volume carry perpendicular height, and this is our curved surface area. Remember, the surface area carries the slanted height. And this is how you calculate the volume and curved surface area of a cone. Let's look at another example of the cone. So the question is, calculate the curved surface area of the cone below. If you can remember, our formula to find the curved surface area is pi r L, and L is our slant height. But if you look at this shape, we weren't given the slant height. All that we were given is h, which is our perpendicular height, and we were given the radius. So we have to now go and find our slant height. And in cases like this, when you're given the perpendicular height and the radius, there's a formula to use to find the slant height. So that formula or we say L is equal to the square root of r square plus h square. So this is a new formula now for slant height, and you know that r is the radius and h is the perpendicular height. So this is our slant height formula. So in order to find the curved surface area of this shape, we first have to go and find what is L, and then use pi r L to find the curved surface area. So let's find what is L. So we say L is equal to the square root of r square plus h square. L is equal to the square root of r, which is our radius, is going to be 5 square plus h, which is 12. It's going to be 12 square. L is equal to the square root of 5 square is 5 times 5, and that is 25, plus 12 square is 12 times 12, and that is 144. L is equal to the square root of 25 plus 144 is going to give me 169. L is equal to the square root of 169 is going to give me 13 cm. Now that we found what is L, we can now go and find our curved surface area. So the curved surface area is equals to pi r L. We know that pi is 22 over 7. We know that r is 5. And we just found L to be 13. So we put them over 1, make them as fractions. So we have 22 multiplied by 5 multiplied by 13, and that's going to give me 1,400 1430 divided by 7 times 1 times 1 is 7 cm squared. 1430 divided by 7 is going to give me 204.3 cm squared. So here you have the new formula to find the slant height. So when you have to find the curved surface area and you're now given L, you could use this formula, find what is L, and then you could go ahead and find the curved surface area of the cone. The fourth shape that we're going to look at today is the sphere. So the volume of a sphere, here you have the formula V is equals to 4/3 pi r cube, where r is the radius. In this case, all you need is the radius to work the volume, and the curved surface area is 4 pi r square, where r is the radius. So to work with volume and curved surface area, all we need is our radius. So, and remember, the radius is the distance from the center to any point in our circumference. Now you have an example over here where you have to calculate the volume and curved surface area of the shape below. So they gave you the radius as 9.5. So let's go and find the volume and the curved surface area. So the formula for volume, V, is equals to 4/3 pi r cube. Let's start substituting. So 4/3 multiplied by, we know that pi is 22/7, times r cube is going to be the radius multiplied by itself 3 times. So that's going to be 9.5 multiplied by 9.5 multiplied by 9.5. We make them the fractions, we put them over 1. So multiplying all our numerators, that's going to be 4 times 22 times 9.5 times 9.5 times 9.5 is going to give me 75,449 cm cube, divided by 3 times 7 is going to give me 21. 75,449 divided by 21 is going to give me 3,592.8 cm cube. And this is the volume of this sphere. Now let's go and find the curved surface area. So curved surface area is equals to 4 pi r square. 4 pi r squared. Let's substitute our value. So this is going to be 4 multiplied by, we know that pi is 22/7, multiplied by the radius squared, that is going to be 9.5 times 9.5, and we put them over 1. Put this over 1 as well. So multiplying our numerators, 4 times 22 times 9.5 times 9.5 is going to give me 7,942 divided by 7 times 1, all 3 is 1, so that's going to give me 7 cm squared. 7,942 divided by 7 is going to give me 1,134.6 cm squared. And this is the curved surface area of this shape. So you have the volume, which is 4/3 pi r cube, and the curved surface area, which is 4 pi r squared. In today's lesson, which was on volume and surface area, we looked at what is volume, and could remember that volume is the space inside of an object or the space that the object occupies. We looked at surface area, and we said that surface area will be the area of all the surfaces outside of the shape. And then we went through the volume and surface area of the following shapes: the cube, the cuboid, the cone, and the sphere. You were given examples, you were given the formula, so copy the formula and then you just apply them to whatever examples you are given. Remember that there is total surface area, and then you have curved surface area. And to remember particularly about the cone that has a perpendicular height and a slant height.